s'en occupait. D'accord. Je vérifie en parallèle que les bons liens ont été envoyés. J'ai un doute. Désolé pour le démarrage un peu complexe.
So now where the students are coming in the Zoom, in the webinar.
All right. There was a manipulation issue from my side. Okay. Welcome, everyone. Sorry for being late. We had some technical issues we managed to overcome, which is the good news. We have the chance today to have a talk from Kering and Eelaman, who will be with us. So very excited to see it. A couple of reminders. This is D-2 before the start of the final sprint that will happen at NSTAR. We have a lot of participants that already registered to this event. So you will see we'll have many surprises on Friday, Saturday, and Sunday. We're all looking forward to meet you all. And I hope you would enjoy it. This talk is food for thought for you to help you work on the case that you will have for today. So take everything that you can. Eelaman is here to answer all of your questions. And if you have any, there is the Q&A box on which you can write and type anything that you need, and we'll go through the backlog during the talk and at the end. So Eelaman, I give you the mic, and thank you very much for being here.
All right. Thank you. Hi, everyone. I think you can hear me. Can you just confirm?
That's okay. That's okay.
Okay, perfect. So thanks for being here today. Thanks for letting me the time to talk about these topics like data science, Kering, and I'll try to talk about energy sufficiency as well. So maybe I can start by introducing myself. So I'm Eelaman Ketheeswaran. I am a former data scientist, let's say. And so I have an engineering background. I joined Kering 4 years ago as a data scientist, and before this, I was a data scientist in a consulting firm. And so, as I told you, I was data scientist, so it means that I had the dirty hands, meaning that I was cleaning data, modeling, doing some understanding the business as well, doing some presentation, the results, everything around the data science job. And for a couple of months now, I am heading the AI Factory of Kering. And the AI Factory is the data science team of Kering. So Kering, I will be presenting Kering just after, but just keep in mind that we work with, let's say, AI algorithm for all the brands that we have. And I'm going to share with you a couple of things today. So I think you noticed that Kering is far from the energy industry. So I'm not going to talk to you about projects directly related to industry, the energy industry, and how we can reduce the energy consumption. However, we have some project that goes toward this, and those are the projects on the supply chain that we have. So this is one first thing that I would like you to remember. And maybe something I can tell you is that as data scientists, future data scientists, you will be able to work in lots of places, lots of industries. So sometimes directly related to energy, and sometimes nothing to do with it, like, I don't know, Kering, for instance. But somehow you can always be moderate in what you do, and this will help you to be better and more performant, let's say. Because when you are moderate, it means that you are choosing the right projects. So those that have the most impacts, you are going to choose the right algorithm, so not too complex. So it has not so many costs to train in terms of energy, but also in terms of maintenance, in terms of interpretability, etc., etc. So second thing, if you have to remember one thing from what I'm saying, is that try to keep it simple as So it's like on the only one best advice I can give you. So I see already messages. Do we take questions? So I don't know how you are used to do this. Is it an exchange, or do you want me to just talk and then answer all the questions? How do you?
We normally have this Q&A box that's on the bottom of the window, so everyone can write any questions. I think might are activated. So we just go through the question one by one, and I can tell you when we have one.
Okay, so I'll take all of them in the end, right?
Yeah.
Okay, perfect. All right, so that was about me. So Kering. So we are a global luxury group. I think Kering is less known than LVMH, but in the end, it's like kind of the same. So we manage the development of lots of brands. I think you might know some of them. To be perfectly honest, when I joined Kering 4 years ago, I knew like maybe 2 or 3. So don't be scared. So we have 3 kinds of brands. We have leather good brands, ready-to-wear brands, let's say, and so ready-to-wear meaning fashion brands, and jewelry brands. The chance we have is that in terms of data, we have lots of things that are already done, meaning that we have a team working on the data lake. So all the data it's not a perfect word, but there are lots of data engineers that works to have data flows from all these brands coming to us in a formatted way, let's say. So it can be used by teams like analytics or AI like ours, etc., etc. So this is one thing. The bad thing about Kering, let's say, and AI and data is that it's a brand where, you know, the fashion is something irrational, and data and science is something more rational, let's say, in our minds. So we as Kering and as data scientists in Kering, we are facing this transformation, let's say this change, to try to make them understand that we can take decisions that are data-driven. So this is some limits we have today. So I was talking about the AI Factory, and the AI Factory is the team of Kering that works with all the brands I was mentioning just before. And our main aim, let's say, is to help them take better decisions, optimize some process, and as I said, taking decisions that are here to optimize things. So we have, let's say, 3 kinds of focus in my team. We work on the operations. So when I say operations, I'm talking about supply chain. So this is the topic we are going to cover today. Lots of projects I will be detailing just after. We also work on client engagement, and this is a nice one to talk about marketing side. So something like client scoring, product recommendation. I think you all know, you all saw something like this, at least for Netflix or anything, even in your lessons, I think. And the last part of our team is, let's say, composed of ML engineer and ML ops, in order to be able to, once you have your model, you've done all the job, you want it to put into production, meaning that you want to serve all your model to be used and to have impacts. So you have to interface all your job to the SE, meaning like the information, let's say the tech guys of the team. Yeah, so you have to think about production super early in your process. So this is why even in our team we have the ops guys. And yeah, as we have several kinds of projects, we also have to be, you know, a center of expertise, let's say, to be able to answer to any question, any problem that our industry has. And for instance, computer vision, time series forecasting, even NLP, we are starting just a little bit on this. So today, the focus we are going to have is next chain operation, meaning that I'm going to talk about supply chain, because this is, let's say, one way for us to impact on something related to the energy sobriety. So maybe before going into the details, I just wanted to share with you some challenges we are facing as data scientists in our industry. So in fashion, in the luxury industry. So we have, go ahead.
Sorry, because you were talking about the tech guys and the SI just before, and there was one question from Jorge, who was saying, can you elaborate on the comment about the tech guys and the go-live process of a new model?
Yeah. Okay. So I said tech guys because I cannot find the DSI word in English. It's like the information system, I guess. Yeah. And the thing is that in lots of big groups, I don't know how it is done on every groups, but in the big groups, the data science team that is transversal to, let's say, all the subgroups of the big corporation. So I'm talking more or less about the ckathon, but I think lots of groups are organized in the same way. The data science team is either in some digital business units or in a information system business unit. And in Kering, it's in a digital business unit. So it means that we have to be sure we talk to the system business unit to be sure that what we do will be used in the end. Is it clear? Does it answer your question? Okay, maybe I can.
Yes, I guess it's good.
Yeah,
Okay.
thank you.
So yeah, what I was about to say is that in Kering, we in the brands we have lots of products. So these might be let's say simple or not, depending on how close you are to fashion. But you also have these kind of products. So with, I don't know, pigs, with like wool in the shoes, or with lots of shining stuff on your shoes. But the thing is that when you are trying to forecast the sale of this kind, the demand of or this kind of products, you never know. Sometimes a product like, can you see my? Yeah, you can see my beam, right? Yeah. So this kind of products. We never expected it to have a huge impact, a huge demand, and in the end, he had it. So we have to forecast it soon enough, so we can, you know, produce enough and replenish enough. So this is one of the big challenges we have, is that the variety of all our products. And then I'm not spending lots of time on this, but we are experiencing this main, let's say, challenge is that all the clients come, not say, I'm not going to say all, let's say a huge percentage of our clients only come once. It means that, I don't know, someone for his 30, let's say, wants to buy some Saint Laurent bag, and then we never see her again, or he again. Him again, sorry. These things means that you do not have lots of data per client. So this is directly, let's say, related to the second point, that is, you do not have lots of signal in your data. Because a product can be sold, you know, it's not like, I don't know, a yogurt or something like this. You do not purchase luxury item that often. So you do not have lots of signals. So this means that as data scientists, you cannot just load a model, your preferred one, and just click buttons, and then hopefully it will have huge performances. As data scientists, and this is one of my message I would like you to remember maybe, is that your force is to model a problem using all the things you learned, the mathematics, etc., so you can adapt to the challenge you are facing in your industry. You have low history on seasonal projects, meaning that you have collections that are only for 6 months, meaning that you have to learn very quickly their behavior. You have high seasonality for some products, and the last thing I don't know if you heard about. I don't think so, because I was not interested about luxury and fashion before joining Kering, but even artistic directors have their own collections, and when they change, the whole behavior of the clients will change. So it means that you have to think to adapt to this kind of stuff. And Gucci has just lost his director just like a few months ago. So this is why a team like AI Factory is needed in a central way for Kering, because we can learn from all the brands and help all the brands with this. So I guess I'll be talking for 30 minutes, maybe less. So I hope you have lots of energy to listen to me. I'll be starting with a little overview of the supply chain. Then I'll be doing a little focus on one of our projects that is called Archimede. And then I'll give you some tips that I think will be useful for you, even for the hackathon, or maybe even after. So this is the plan for me. So if it's okay for you, I'll move on. All right. So here you have a simplified version of our supply chain. So I'm not talking about the design of a collection or something like this, because this is out of the supply chain and is before. And for instance, when you have a product that is in store, so when you go to, I don't know, les Champs-Élysées, and you go enter a Gucci store, when you see a product, if it's the new collection, it means that it has been produced at least 6 months before. Okay, so you have some lead times in your forecast. So I'm going to tell you why it's important that you keep this. But yeah, you have lots of lead time at any time, any steps of your supply chain. And before the production, there is the design. So it means that when you see, let's say, a bag in a store, it has been designed, I don't know, 1 year, maybe more. It has been designed before. Then it has been produced, and then it has been replenished in warehouses. And then, so warehouses are just big rooms where we can store anything like the products, I mean. And then you have to replenish to the stores. And then we have some other stores called outlets. An outlet is just a store where a product ends its life, and so we can make some discount on the products. Okay, so now you have this. In the end, you have 3 big steps, let's say. You have a step where you have to produce. You have a step where you have to allocate, so meaning you have to choose where to go, where goes which products. And then we have a step to decide the price, to be sure that all the stocks you have is going to be sold. Because one key thing that is like new to Kering, new I mean for 2 or 3 years, is that before it was not a problem. You could always create lots of stock and then trying to sell it, and if you do not sell it, then you can just destroy it. and the high margin that all the luxury brands we have will enable this kind of behavior. But now all the like legally you cannot do this anymore. So it means that you have to produce the right quantity so you do not overstock, because having a stock then is like terrible, because it's like cost, energy, everything that you can think. So yeah, so this is where we have lots of projects. So the project I'm going to talk about today is this one, Archimede. So a long-term demand planning in order to produce the right quantities and limit overstocks. But we have lots of projects. So optimize the size of the carton, the box, sorry, to deliver products. We have projects to make short-term forecast, meaning that when you have all the products, you have to find where to replan the right quantity of the right products. So using short-term forecast. And then we have product pricing optimization. We have, so pricing optimization basically is like elasticity curve that you, because you are trying to having the maximum price while decreasing the stocks, but keeping also, you know, the image of our brands, because you cannot just sell anything to, I don't know, 200 euros in the luxury industry. And the markdown is like another pricing project. All right, so let's deep dive in Archimede. So what is Archimede? In a nutshell, the business objective is to optimize the production. So we want to reduce overstock, but we also want to avoid stock out, because we have to find the right balance between overstock and stock out, because if we are stocked out, then we have clients that are unsatisfied, then we have delays in the production, then all the system is panicking. So we have to be not perfect, but in the right level. And so the project objective here for this one is to give a long-term forecast. When I say long-term, is for 3 to 18 months, let's say. Month by month, the quantity that we need to produce. So I just wanted to show you a concrete example, so then I can deep dive on the method we are using. So here you have a moccasin, the Jordan in the white color, and here is the demand curve. So sorry for the vertical axis. I know we are told when we are in school that we always need to put axis and title, but I cannot put the vertical axis here. So you have the volume in the vertical axis, the time in the horizontal one, and the question is in January 19, what will be your forecast? How would you do to make a forecast for the demand in North America for this moccasin? So there are plenty of answers. I see a question. Is it an answer to my question, or?
A question about do you deal with aggregated demand or just a forecast by store?
Yeah, that's a good question. It depends on the project. So in the end, we have all the levels of forecast, because, for instance, if you want to replenish the right quantity to the stores, you have to go to the store level. But if you want to produce here, yeah, this case, you do not have to go to the store level. You can go at region level or country level. So here I'm talking about a region level. Yeah, so one answer that you can have, one strategy that you can have is trying to deseasonalize this time series, so meaning that you are going to remove seasonalities like Christmas, etc. I was about to say Chinese New Year, but you are in North America, so there is no that much Chinese New Year. But even though you have lots of things that you have to consider, and once you decentralize it, you can take an average of it. So you have something like this, and then you can seasonalize it again. So apply some coefficients to have something like this. And this is one simple method we try to have in the beginning, but then we faced some limits. Here, the limit we are facing is that its hypothesis is that these products will have, let's say, a fashion curve that is flat, meaning that you will always have, the same level of demand, the same level of virality. I don't know if it's English, but the same level of fashion, let's say. But that's not true. And this is why we, and this is what you see in the data. So here in blue, you can see the sales, and actually you see that it decreased in the end. You see the seasonality was okay, but it is decreasing. And so here with the first model, we were over forecasting. And what we did is to model the life cycle of our products. So maybe I'm going to talk about something you already saw in your lessons, and it's the Bass diffusion model. So if it does not, don't be scared, I'm having a little focus on it in a few minutes. But the idea is just to model the life cycle of the products in the same time of the seasonalities. So this is something that works better for us. Of course, nothing is magical. I took a good example to share it with you. Sometimes it does not work that well, but in the end, overall, it works like this. So we have a model that is a combination of 3 models. First of all, a Bass diffusion model, and I'll be detailing it in a few minutes. Something related to seasonalities, and this is computed in the same time with market trends with profits. So profit, I guess you already know what it is, and it's like an algorithm from Facebook for time series forecasting. And just to give you a little bit of content of Bass diffusion. So this is just a model that is used to predict, let's say, a product penetration, for instance, or let's say the number of people that are joining, let's say, even a social network, for instance, etc., etc. Because for instance, when you have a new product, you have 2 kinds of people. You have the innovators and the imitators. And here we try to model it by 2 parameters. The P parameter, that is the innovation rates. So actually the fast fashion people, the people that are always aware of what is trendy, etc. And these are the innovator. And then we have the Q parameter that is modeling the imitation rates. So, and I did not talk about M, but M is globally a proxy of the demand, the overall demand. I'm not projecting here the equation, but it's just an equation, a mathematical equation with 4 parameters because there is the time. So 3 parameters and the time. And we try to model MPQ for our products so we can have a curve that is between this one and this one for all the products. So I hope you understood that here this curve is something where you have lots of demand in the beginning of the product's life, and then as there were no imitators, it's decreased super quickly. The second one is something that where you talk to more people, so you had more imitators, and then there is this increase, and then there is a decrease because there is no magic. Every product has a life cycle in the end. So this is how it's like one of the hearts of Archimedes. And we use a Bayesian approach. So again, I'm not going to teach you what is Bayesianism, but here what we do is that we try to use the maximum of the information that we have at any time. Because one big challenge we have is that when you have a new product that has no history at all, you need to make a forecast for it. And then for each week of sales, you need to integrate this data with the, let's say, the maximum form of information that it has. So what we do is to build priors using all our historical data where we have lots of history. And once we have priors, then we update them with the data we have. And this curve is exactly showing this. So here in the beginning, we are not so good because we are using priors. And then as soon as we have some data points, we update them. And then we have a model that are more suited to the products and more accurate. Hopefully, you are still understanding me.
Hopefully.
Perfect. If you have any questions, do not hesitate. I'll be happy to answer it, even now or later. And one thing is, so here I can talk a little bit about simplicity and sobriety. In the beginning, we tried to build our priors using a computer vision. So the idea is you want a forecast for this shoe. One good idea is to say, okay, maybe I can find all the products that are looks alike this one using computer vision, and then taking their MPQ, let's say, and then use it to model this one. So we used ConvNets to have a distance between products, etc., etc. And in the end, it was not so good for several reasons, but one of them was we did not have the, let's say, the right information in the training of our ConvNet, let's say. And one other thing is that we had high variance results, meaning that we tried to reduce too much our bias, and the parameter we managed to have were only suited to these shoes, but not to all the shoes. So this is something I think you've heard about, the bias variance dilemma. I also heard about it when I was a student, and I was like, okay. But this is maybe one of the biggest topics you need to focus on in your studies as data scientist, is that in the end, you need to have a low variance, because if not, your model are too complex, and then it cannot be maintainable in the end. So from ConvNet, we went to just a linear regression with way few parameters, no images, etc., etc. And in the end, we achieved better forecasts, but also better time to market to roll out to other departments. It is more maintainable. It also costs less, and in the end, it's more energivore. I don't know if it's English, but consume less energy. I think I see a question.
It's more a congratulation from Dan. It's great so far. I hope we have a chance to talk in details.
Perfect. Okay, so that was for the detail. So nice timing. And now I have some tips I can give you humbly. So because I guess I can talk for all our team, and we learned some things. So I can share this with you so you can learn it before us. And I think you can apply it very soon. So the first topic I would like to discuss is that as a data scientist, you are trying to solve a problem, and you are not giving a model, but you are going to answer a question that needs some optimization somewhere. So this joins what I was saying about, what I was talking about just like a few minutes ago. You have a power that not everyone has. And if it's just a matter of, I don't know, doing import Keras load some model and some product, this every software engineer, every person that can Google something about Keras, Tuto, and something else will be able to do this. You have to understand deeply what is the problem you are trying to solve, how it will be used, and how it will be evaluated. So this is one thing. And then what are the data that you can access? So what data is available? What are the specificities of this data? For instance, as I said, in luxury, it's not the same specificities as in a bank or in energy or other industries. Who are the user of the solutions? What do they need? I think all of this you have to keep in mind for the hackathon, because for what I know, but maybe I'm wrong, you also have to make a presentation. So it means that you have to talk to people and convince them that your solution is the right one. And if you are not speaking to what they need, I mean, if you are à côté de la plaque, next to what they need, you cannot win in the end, even if you have the best model that optimize the best performance metric, etc., etc. And the tool in which it will be integrated, that relates to what I was talking about the information system you are working in. All right, and then some little final tips I can give you. So these are not only in order to be, let's say, energy sufficiency friendly, but in the end, it's top tips that you will need anyway. So this one, the first, I put it here because I would like you to remember it, even if it was the topic I was mentioning just before. There is no order. So I put 1, 2, 3, so you can refer to it if you have a question, but there is no order of the best or the second one. Do not reinvent the wheel. It means that it's tempting as a developer, data scientist, to recode lots of stuff because we like it. But if you want to be efficient, try to do not reinvent the wheel, meaning that if you are trying to do something that seems to be common, someone maybe has did something on the huge packages that you already know. So this is one first thing. Second thing, this is maybe one of a big, let's say, advice I can give you. So do not choose a big bet to kill a fly. Meaning that do not introduce complexity unless it is necessary. And again, it's a bias we all have to have fancy algorithm, etc., etc. But again, what we need as industry, but what we all need in the end, even for the energy sufficiency, is to be moderate. So this is one big I think tips that you should remember. Other thing, do not over-optimize your performance, I don't know, by killing a polar bear because you are going to make a big, I don't know, hyper parameters tuning for just a little increase in your favorite metric. I don't know what you are using, what metrics you will be using, but in the end, I think even for the hackathon, I don't think that you will be judged, but take this with pincettes. But I don't think you will be judged on the PM of the performances. So try to stick to the problem, and if we need 0.01% of performance, then you will be told. So you will optimize it, but it's not the first priority. Think about interpretability of your models, because you need to convince the people that are going to use it. And this is directly related to the simpler the better. Keep the things simple, because if your model are simple, then they will be easy to interpret. So you have to keep this. And in most of the case, I mean, I think I don't have a number, but in most of the case, your models will need interpretability, because you are talking to business people, and if they do not understand how your model works, then you cannot convince them. This is something I think you do not need in the hackathon, but something you can remember is that you actually do not have to retrain in lots of cases. Again, in lots of cases, you do not have to retrain your models every day or every week or every nothing. Unless it is necessary, so it means that your data are changing a lot, etc., etc. When you train a model and you put it into production, then you can watch, monitor any drift that you have. But if you want to be sober, then start to not retrain, I don't know, all your algorithm anytime you want to, anytime you want, yeah. And the last one is you can anticipate early how your project algorithm will scale. Again, this is more in the future, but if you start in a project and you do not think a little about how it will scale when you roll out to other, for instance, for us, when we roll out to another country or another brand, another product, if we do not think of it earlier, but in the end, because just maybe what you don't know is that when you start a project in a company, you start with bugs, then procs, then pilots, and then production. And in all of these steps, you try to be sure that you are going to be able to reach the production level. Okay, so even if your algorithm does not scale yet, try to think about it, and you can talk about this with the SC already or other people. And that was all. So one thing that you think that you should remember, I think, is the simpler the better. So it's like the only best advice I can give you. And thank you for your attention today. I can tell you to have fun during your hackathon, because it's easy to be, in the competition, etc., but it's a great opportunity for you to learn. So sleep well. I can tell you, because when I was doing hackathon, I was not sleeping, and that's not helping in the end. So sleep well and have fun. And now I can answer all your questions.
Okay, thanks a lot. And yeah, must have fun during the final sprint. We have one question again from Jorge. When does it make sense to reuse a model? Any recommendation on the criteria to decide whether to reuse versus start from scratch?
Sorry. So it was George, right?
Yeah.
Okay. When does it make sense to reuse a model? Any recommendation on the criteria to decide whether to reuse or start from scratch? Actually, it depends. But one thing you can do is the simplicity principle. Try to reuse what you have, and then if it's necessary, do it from scratch. But I cannot give you an advice that is like, when is it the best, let's say, the best method to use something that is already done or not. So yeah, I cannot tell you precisely. Sorry.
Another question from Sonia. Question from a non-data scientist. Point 6. Do not retain a model. Generally speaking, how is retraining done to understand to not doing it? That's quite
okay.
inception of yeah.
Okay. So training model, meaning that you are going to have an algorithm that is going to find patterns in the data you are inputting it. Okay. And this, depending of the amount of the data you have and depending of the complexity of the algorithm you have, will consume computational power, and computational power is in the end energy. So if you do not have to readjust the parameters of your model, so a model is nothing more than a set of parameters that are learned from the data and that can be used to make forecasts. So this is for the training part. And when I was talking about the training frequency, I just said that in the huge, not huge, but in lots of cases, your data are not changing so frequently. So in finally, you can go toward energy sufficiency either by your projects that you are going to do directly related to, I don't know, Schneider Electrics. I think they have lots of projects that are directly related to energy, Total as well, etc. But when you work in other industry, you can try to be sober, but not sober, moderate, but by the way you work. So this is let's say, one of the message I would like to convey, and this will help you not only for energy sufficiency point of view, but everything else. As I said, interpretability, maintenance, even if you want your projects to have a long life, because the data scientist market is tense, meaning that data scientists are not staying lots of time in the same company. And if you want your baby to stay longer than you, let's say, you have your model to be simple, so the handover is simple, and then it will be something that lasts long, sorry.
Thank you. Super clear. Is there any other question, or what we still have 5 minutes with Eelaman on the call?
Maybe I have a question. Eelaman. So you were talking about building some forecast for you for the demand of your product. So at some point you are using Bayesian modeling. So how frequent are you updating your prior? Is it, you said that every time you have a new data, but what does it mean in practice? Every week, every month, every day?
So our priors, we are not updating them super often, because in the end, we trust our priors to be okay enough, let's say. And then every week, when we have the demand, meaning that we have the transactions that have been done, then we can input this data to modify our prior, shifting to the posterior for each product.
Okay, sorry. So my question was about the posterior. So how frequent do you update your posterior distribution?
Every week. Every week.
Okay. And so maybe another question about a risk you mentioned, but you mentioned at the beginning that it was quite risky not to have a incorrect forecast because okay, you have to find the right forecast, not to product too much, but also not too less. Okay. So how do you manage this risk? Is there any this risk?
That's a good question. So here, when we make a forecast, we are talking about the expectancy, l'espérance, the mean of the forecast. But we have for our Archimedes model not only the average, but the distribution.
Okay.
So it means that we can use the quantiles to try to model, to play with the risks that we would like to take to make an order when you have the forecast.
I see.
That's a good question because initially we only had like the mean, but the mean is not enough when you have lots of variance. So yeah.
Clear, very clear. Thank you.
Hopefully it was understandable for all of you, and it will be helpful for you. So if you do not have other questions.
Yeah, I think if no questions, we can close here. Thanks a lot for this, and thanks a lot for the advices that you gave regarding the final sprint this weekend. Indeed, we need sleep to make sure that you have something up and running at the end of Sunday. So thank you very much, guys. If you have any questions for Eelaman, please don't hesitate to send an email to the organization team. You can make you in contact with them. And I hope you enjoyed your evening.
All right.
Thank you. Bye.
Bye.
Bye. Bye. Bye.